Hello people, how are you doing? Today we are going to use this particular calculator, photoelectric effect calculator, and the constants we are going to use are speed of light in vacuum, also Planck's constant, charge of electron and mass of electron. Okay, you can use the approximate values or you can use this particular button and use the exact values. Now you get to see the exact values are here. Then again you can use the same button again. This time it reads use approximate values, and you can also change values like this. If you think you should use 6.626 into 10 to the power minus 34 joule second for the value of h, which is Planck's constant, you can do that. Okay, so we are going to solve two math problems by which I am going to demonstrate how to use this particular calculator or app. Okay, there are there are a few input sections. This is the first section, incident photon or incident light. This is the second section, work function and threshold, like literally work function and threshold frequency or threshold wavelength. And then this is the third section of input emitted electron. About this max kinetic energy, stopping potential Vs or max velocity. Okay, so you will input as much info as you can, and you will press this particular black button which says calculate and show stops. As a result, the step by step calculation results will be shown here in this particular box, waiting for which reads waiting for calculation. You will get to see the calculation, and below this you will see the summary. Okay, so let's first tackle two math problems. We shall try 29 and 30. 29 says when light with a wavelength of 250 nanometer falls on the cathode of a photocell, the potential is 4 volt. This must be the restraining potential, right? Okay, so we know the incident wavelength and also the restraining or stopping voltage, but we don't know the work function. If the wavelength of the incident light is increased to 300 nanometer, determine the stopping potential. So in these two cases, see, the initially wavelength was 250 nanometer, but this time it is 300 nanometer. The initial potential, restraining potential, was 4 volt, and we have to find the final potential, which is supposed to be 3.176. The only quantity that remains constant here is work function, but which is unknown. That's why we shall use the first two values, 250 nanometer and 4 volt of restraining potential, to calculate the work function. Once we have found it, we shall use this value 2 and also use 300 nanometer to calculate the new stopping voltage. Okay, so let's try the calculator. Okay, so in here incident photon, there are few sections that you might have seen already. You can input either the frequency or the wavelength or photon energy. For the photon energy, you have two units like joule and electron volt, and for the frequency you have only one unit, which is hertz. But for the wavelength you have several units like meter, millimeter, micrometer, nanometer, picometer, and angstrom. So in our particular case, in the first case, the wavelength is 250 and this is nanometer, if you can recall, and the stopping potential is 4 volts, right? Okay, so we will simply calculate and show steps button. Here are the step by step calculation. Suppose take this for instance, kmax. Okay, forget this. Think about this, the work function. we have forgotten to put the subscript 0. The work function is calculated as 1.5512 into 10 to the power minus 19 joule, but in the summary table the work function is given in also in electron volt. So we shall use this value 9695. Let's use this. First of all, since we are going to do another calculation, we have to clear all fields. So 97 I already forgot. Let's put 97 simply, 9625, probably this. And this time in the new case or second scenario, the wavelength is 300 nanometer, if you can recall. Now we are going to press the calculate and show steps button, and as a result we see this. What is the stopping voltage in this case? It is 3.1787. So as you can see, this is the result we are expecting. Let's try the next problem. Problem number 30. A UV ray of wavelength 3000 angstrom incident on surface of an object with work function 2.28 electron volt and emits an electron. What is the velocity of emitted electron? So these are the two data we need to collect. 3000 angstrom, this is the wavelength of the incident photon or light, and 2.28 is the work function EV. So we have to find the maximum velocity of the emitted electron, which is supposed to be 8.08 into 10 to the power 5 meter per second. But in this case, for this particular problem, we have to use 6.62 as the value of Planck's constant. Okay, so let's try this. First of all, we will clear all fields so that we can input nice and smooth. As you may recall, the wavelength of the incident photon is 3000, and this time it is not nanometer, it is angstrom, and the stopping voltage is not the stopping voltage, probably the work function 2.28 electron volts. So we could have chosen joule also, but in this case it is electron volt we are choosing. Okay, now we are going to press the calculate and show steps button, and as a result we find this, the maximum velocity 8.090. Why is this? It was supposed to be 8.08. Let's try this one. Let's press this button twice, exact values and then approximate values. Now we are going to press this button once again. Let's see, it even increases. Probably we have input something wrong. Work function of 2.28 electron volt is fine. 3000 it is also fine. Oh, we have forgotten about 6.62, so let's fix that. Here instead of 6.63 we have to choose 6.62. Now we are going to press this particular button once again, and let's see what happens. This is the maximum velocity of the emitted electron, which is 8.082 into 10 to the power 5 meter per second. Okay. And if you are interested to know the calculations how it came, here it is shown. See, Vmax is this. How? Vmax is basically equals to root 2 K. K stands for kinetic energy divided by electron mass of electron. So if you plug in the values here, like the kinetic energy, 2 into kinetic energy and then divided by mass of electron, you get this particular value. This particular point, as you can see, the first point here, 2 point, This is multiplication or product, and the next point you see it is decimal point, so that's the difference. So although these things are not exactly very beautiful, but they give you a glimpse. Okay, and one particular very special feature of this app is that you get to see can have the exact values. So this time it is the exact values of the constants. Now let's press this button once again and see what is this thing. 8.073. This is more accurate value, very closer to the most accurate value. So their value, the value they have given, like 8.08 10 to the power 5, this is not the exact value. This is a little far from the exact value, and also our value, which was our previous value, which was 8.082, this was also a little far, but the exact values is supposed to be 8.073. So this is the cool feature of this particular app. You will get this on the URL. Let me show you. Zakir Buet, which happens to be my website /photoelectric.html. In the Bangla version, there's a hyphen between photo and electric, but in the English version, there's no hyphen. And also on the WordPress version, you will find this, but you have to get rid of .html. I have another website which is currently inactive, but I'm going to activate that within a short span of time. In that case too, in that website too, you will find the exact app, which is the URL would be zakirbuet.net/photoelectric.html. Okay guys, thank you for your time. Have a great day.